And today I get to spend time with Todd Collins, air sealing insulation expert. Todd, thank you so much.
Thanks for having me on.
Man. Now, you've worked on this home of John's on a number of different occasions, and airtightness is a critical piece.
Right.
Share with us why it's so important to have a great airtight home or building.
Some would say that a house needs to breathe, and it really doesn't. It needs to be vapor open. You want it as tight as possible, because if air is getting into your walls, so is moisture.
Yeah.
And one of the most important, I guess, one of the biggest problems with buildings, or one of the issues, is if moisture gets into your house, or into your wall assemblies, it will actually damage the walls. So the airtightness really is important in keeping the air out of the walls, which you're keeping also moisture out of your walls.
Yeah.
So that's number one. Number two,
If moisture gets in, mold can grow.
That's
in the
right.
worst case scenario.
you get rot, you get mold, and it can be very dangerous. Actually, physical illnesses can be tremendous from mold. And we saw that in Boulder when they had the big flood back in 2014.
Right.
So in the end, airtightness is absolutely critical. One, for building science purposes, but also for energy losses.
Yeah.
You lose a lot of heat. And some people would say with a code built house from 1970s that 30 to 50% of the heat losses are from air infiltration.
Yeah.
Air just going straight out your walls.
And I'll add to that, I know some of the studies that were done with the Marshall Fire victims from 2021, air leakage was a big part of causing spread of fire.
The embers
through
would
the
get
wall.
into the buildings.
Yeah, come in through the attic,
Correct.
vents and down into the home, or even in through the wall assembly, or crawl space vents in.
Yeah.
So
Soffits as well.
yeah,
exactly.
So a huge part of that.
Yeah.
So what is a good level of airtightness, and then what's a great level of airtightness?
Well, in 2018 was the first code that required an ACH 50 blower door test.
Okay.
So what
Air
that
changes
means,
per hour at 50. Okay.
at 50
Yeah.
pascals,
Yeah.
so they pressurize the house to 50 pascals, or they depressurize it. They'll either suck the air out or push it in.
Yeah.
And they measure how much of the air goes through that fan and then against the volume of the home. So it's air changes per hour.
Right.
And a typical house in the 1970s might be 10.
Yeah.
And in 2018, they finally, in code, required a 3.0 or less.
Yeah.
Now, that's okay.
Yeah.
Passive
Big
house.
improvement over where they've been, but yeah.
Passive house, a German energy efficiency standard, requires 0.6 or 5 times more tight than what our code here in the US requires today.
Yeah.
So that, in my opinion, is a good airtightness measure, is 0.6. And I know John has really worked hard on that. And
Right.
with a retrofit, it's a lot harder. With new construction,
Yeah.
it'll be easier.
Yeah.
And I think John's at like a 0.9. Is that correct?
Mhm.
0.9 ACH
Okay.
50,
Yeah.
which is a great number for a 1980s home.
I can say I had the pleasure of doing many of the blower door tests on John's homes, and when he started, he was much leakier than that. But now he's almost at passive house new construction levels of airtightness, and it has a lot to do with products that you guys helped get installed.
Correct.
Into your zone.
So John used what's okay. So Siga is a manufacturer
Yeah.
similar to like Tyvek. Tyvek's a brand here in the U.S.
Mhm.
Most people know. Siga is a product out of Switzerland, and there's a membrane that goes on the exterior, and it's a blue membrane. It's
Yeah.
very strong, and it's like Gore-Tex for your house.
Okay.
So the way to think about that is Gore-Tex will allow vapor or sweat, in the case of a jacket, out of your jacket.
Yeah.
And that's exactly what you want. You want the walls to be able to dry.
Yeah.
You don't want them to breathe.
Right.
You want them to be able
dry.
to dry.
Yeah.
And then on the
It's the
inside,
long underwear on the home that's everywhere, but letting your sweat out. Letting the moisture
exactly.
out.
And on the inside, you would use a more vapor closed product that there's now smart membranes that are dual membranes, what's it called? The dual permeance membrane. So it won't allow moisture into your wall, but it'll allow it out.
So
Similar to a cactus skin. So cactus skin will allow moisture into the cactus, but it won't allow the moisture out. So some of these smart membranes are truly very smart.
that is awesome because it just it covers you in case something bad happens upstairs bathroom. You get a little water or a lot of water spillage from the kids.
Well, the humidity.
Or the humidity, just in general.
Just diffusion.
Yeah.
Alone.
Just
getting into your
that.
walls.
Yeah. And instead of trapping it in there, it's drying in or out.
Correct.
On
So if your
humidity outside.
vapor open to the exterior is ideal. We have a different situation here, and we'll go through that a little bit more. But generally in the US, in any really climate, you want to dry to the outside because the inside, well, let's back up. Moisture or vapor is similar to heat in that moisture or vapor moves to where it's dry. Heat moves to where it's cold.
Yep.
So heat moves, not cold. Moisture moves to where it's dry, and we generally are more moist inside the building than we are outside.
Especially here in Colorado.
Yes, well, we're breathing, we're cooking, we're showering, we have dogs, we have plants that are releasing moisture into the air. So it's often more moist inside the house than it is outside. Now we're in a more forgiving climate because it's high desert plain.
Right.
So we can dry to the inside, which is a good thing.
But it's better to just build it to try and dry it whenever you can towards the outside.
To the exterior,
Yeah,
true.
beautiful.
And this would be an exterior tape made by Sega, and it actually has a perm rating. It allows moisture through it, believe it or
Okay.
not. Now this is
Obviously
the
no water liquid would get through it, but water vapor
yes.
can come through it.
So I've actually made a bucket or made a bowl out of this material and
A bowl.
pushed it into a 5-gallon bucket.
Nice.
And then filled it with water. And 6 hours later, no water had gotten through it.
Oh, awesome.
So it's vapor open. It allows moisture out, but it doesn't allow bulk moisture through it.
Okay. Beautiful stuff.
Yes.
Thank you on that. So when a home is tightened, a lot of people have concerns like, when does it get to be too tight? Or what can happen, or what do you do?
It
to
can
address
never
it?
be too tight.
Yeah. Good.
So in short, you want it as tight as possible.
Good.
The key is once you get it very tight, you have to mechanically ventilate the building. So
Yeah.
make it tight, ventilate right.
Right.
I have a shirt that actually says that.
I love that. John's got a great, ERV, I guess
Yes.
a SEER
CERV, which means
yeah.
conditioning,
Yeah.
energy recovery ventilation system. So serve.
Yeah.
And the conditioning part means it does provide actually some heating and some cooling. So it uses a heat pump to do the heat exchange.
Okay.
So an energy recovery ventilation system generally has like a diamond-shaped core. Air goes through, and the heat that's going out, meaning you're pulling it out of your house, is actually transferred to the incoming airstream in the winter and vice versa in the summer. So the heat moves again, not cold.
Right.
So when it's in the summertime, the hot air coming in goes right back out. Not the hot air, but the heat goes right back out. We get that fresh air in, but we're keeping heat where it belongs.
And that is so beautiful. So once you've done really good things to tighten a home,
Yeah.
and it's not easy in a retrofit. It's not an easy thing.
That's
but
one of the
there's a lot
toughest things,
Yeah.
even in new construction.
Yeah, to do it right. But having products that are air sealing tapes help tremendously if you're taking the siding off for whatever reason, or because you want to maximize your performance the way John has done on this home. But tightening it from the outside is best, but you can also do air tightening on the inside, trying to seal around outlets and penetration
Correct.
throughout your home.
And
doing
John's
that.
done just that. He has
Yeah.
insulated all and air sealed all of his outlets.
Yeah.
Which is a lot of work.
Yeah,
So
it's
hats off
not
to him.
easy, but yeah, it's beautiful stuff. So once you've done all that, then the insulation. So we go from the Gore-Tex, got the underwear that allows us to.
Well, it's the shell.
Yeah.
Let's call it the shell. Let's
That-
think
that's
about
the
we're on
shell.
top of a mountain.
Mm-hmm. Yep.
We've got a down jacket.
Yep.
And the insulation in the down
Yep.
is the down. And then
The shell.
the shell is
Yeah.
is the air barrier.
Yeah.
Now, and also important is we got a zipper.
Yeah.
If we don't zip it up,
It's-
it's not going to work
And
very
that's
well.
the airtightness.
That's the airtightness
It's zipping
component.
things up, otherwise
Exactly.
it's not going to be so good.
Yeah.
And putting a hat on as
There's,
well.
especially for me.
Exactly.
So they put a 1-inch layer of its EPS. You can see it's white
It's
foam.
like styrofoam cup type of material.
And that EPS then creates a thermal break from the studs to the exterior, which is great. And the more, the better. And that's why John has added another 6 to 8 inches, depending on where in the building. 8 inches below grade, 6 above grade. to further break the thermal bridges in the wall assembly, those studs, essentially.
It's a big part of why his house stays so even in temperature. Even if it's hot outside, even if it's cold outside, his house stays so much more comfortable and so much more even, because he went from a baby's blanket wrapping around here to where he put on, a quilt and a comforter and, a very thick comforter. He went and did it fantastic.
That's a good analogy.
Yeah. So
yeah, the key is there are some challenges with exterior insulation.
Okay.
So we just talked about drying to the outside.
Right.
And if we're adding, say, a foil-backed EPS to the outside in extruded polystyrene, expanded polystyrene. The foil, though, is a vapor barrier.
Right. So it's not going to let the vapor transfer anymore.
Exactly. It doesn't allow the moisture out of the building. So you have to dry to the inside. The polyiso is also vapor closed.
Right.
So that, again, when we get back to building science, does not allow the building to dry.
Right.
Again, we're in a forgiving climate, Colorado, high desert plain, so we can dry to the inside as long as we're not actively humidifying our homes.
Yeah. Or maybe a lot of aquariums or something like that. You might have a big challenge with that. But generally, actively adding humidification. I know a lot of people that move to Colorado say, I need to have a humidifier. I need to have that, my skin, my hair, and everything like that. You got to know, as Todd's saying, you're putting yourself in a bit of a risky scenario.
The cracked cuticles in the winter are not fun.
Yeah, they're not fun, but it's like better to use a moisturizer, right?
Exactly.
Yeah.
Well, and one thing that's really important with high performance houses or homes, because they're airtight, they're more humid anyway. You're not losing the humidity through all these cracks in the walls, and you're getting to a lower humidity level because the outside humidity levels are so much lower, drier. Yeah. So we find that in a high performance home, you're running 45%, pretty standard in a high performance home.
So it's another reason to tighten your home. If you're concerned about having your skin and your hair dry and furniture dry, the more you air tighten your home, the more the moisture is going to stay in the home, and the more humid it'll be. And
which is nice in the winter, especially here.
Because I mean, ideally, like for our health, you should be 35 to 50% humidity, correct? In that range. That's like ideal for lung health and throat and sinuses and things like that. So it's like
basic
up your home
wellness. Exactly.
It's a really good way to do that. So in the case of these insulations now, I mean, John's been doing this for years. He's been working on his home for a long time and using materials that are, at the time, cutting edge.
Built in '82 and never stopped working on it.
Going on, which is outstanding. So it's a living experiment of what's been progressing over time. But now, oftentimes, people aren't doing polyiso-cyanurate foam, but they're doing things like mineral wool. Right?
Yes. Well, and the key is if you're only doing an inch, you're running a fairly significant risk. So if air is getting into your wall assemblies, it's bringing with it moisture.
Okay.
So in the winter, you have a cold surface on the exterior, that air comes in, that moisture comes in. It's like the glass of ice water on your picnic table. It sweats. Condensation forms on that glass, and it'll drop right to the table. Enough of it. So that happens in your walls.
Right.
Is
so
that
if you add just this, or maybe even just this without everything else?
You might not be moving the dew point out of the wall assembly. So only 1 inch will not move the dew point out of the wall assembly. But this, with the extra quilt and the extra down comforter, he's definitely moved the dew point out of the wall assembly, and he runs very little risk of having condensation on the inside of his wall assemblies.
So just to re-emphasize what Todd's saying, it's so very important. If you're going to take off the siding because of a hailstorm, the siding's worn out or things like that, like, oh, I'm just going to put an inch on, it's cheap, it's going to help, right? It is so much better to go thicker, at least about 3 inches usually, right?
And this is where you would want to do an energy model or a hydrothermic analysis, which is...
Yeah, it gets very involved, but you'd want to do the analysis for your home depending on the elevation, the climate you're in exactly, but don't just immediately say, oh, 1 inch is going to be great, let's put it on. So think about that, get some expert help with that.
Or use a vapor open insulation material. This is mineral wool board. And instead of ISO, we would use this mineral wool board, and it has a perm rating of about 30. So it allows moisture through it, and it allows the vapor to actually diffuse through the materials, and then the wall assembly can dry.
So real quickly, these are made primarily from petroleum, but
Right.
that is coming from
Rock.
Yeah. Isn't that
It's-
weird? You can insulate with rock. Right? Okay.
Yeah.
I know. So,
And it's fairly rigid
Yeah.
and compressed. It's got reasonably good compressive strength. The key is it's made with usually recycled slag.
Yep.
So leftover slag from the steel processing industry,
right.
and then they add about 15% virgin basalt to the material. And what they do is they heat it up to 2200 degrees and it turns into molten rock, and then they spin it like cotton candy to create fibers.
Right.
Those fibers are then compressed into bats and boards.
Right. And even though 2200 degrees in a furnace is using a fair amount of energy, that's a good use in that case of a fossil fuel energy. As they continue to do that, some of them are switching to electric, for as what I've seen in one article. But like, that's a good use for it. And the energy going into that insulation, you get back quadruple, sextuple, you get multifold over again in the savings that you're getting from
Correct.
that product. So
And you get-
fiberglass is made in a similar way. It takes a great deal of energy to make it.
About 1300 degrees
Yeah.
versus 2200.
Right.
Yeah. Glass melting point's a little bit lower.
Yeah, right. So sweet.
Yeah.
Well, thank you on that, and that's absolutely outstanding. So
Yes. So that is, in my opinion, if you're going to use this very narrow or skinny layer of insulation, you want to go.
that.
You want to go to the mineral wool.
That's the safe way to go. So,
Exactly.
So if there's a siding company talking to you about just putting an inch or less than 3 inches on, make sure to say, I need an insulation that's vapor permeable. So something like a mineral wool. And they'll be like, where the heck did this person get their information? So
Yeah, right.
But ask that question. It's a very good way to go. So Todd, you've been in this industry since 2011.
Yeah.
And so tell me why. I mean, you've got a great deal of knowledge. You're doing great work with people, but why did you get into this? What was your journey to get to this point?
And I'm going to go way back.
Okay.
And apologies. And I'll try to keep it short.
Are there diapers involved?
No, well, yeah, sort of.
Maybe. Okay.
Not mine, but
Okay, good.
in high school, I actually wrote a
Okay.
paper on passive solar design. And kind of glummed onto it. I actually enjoyed it, and it was one of those topics that I just kind of enjoyed, and almost did an architectural degree after that. For college. I didn't. I ended up going liberal arts because I heard what an entry-level architect could make. So I'm like, oh, I need a job that can make money. I'm going to have a lot of debt. But it's always been in the back of my head, the built world, the building world in general. And I had gotten into software sales eventually and was traveling a ton when our kids were born. So there's two primary things going on here. One, we had children and I needed to travel less. And two, we had children and I thought, we're setting our future generations up for a massive failure down the road. And I need to do something more meaningful with my life and not do software sales. I need to find an area where I can actually make an impact related to my kids. So I started jumping into this area of passive solar design again. And in the process, I found Passive House, which is that German energy efficiency standard.
Right.
And it made a ton of sense to me. So I took the training with PHIUS, which is the US version, PHIUS, which is Passive House Institute US. And my intent was to determine how I could play a role.
Okay.
What holes are there? And there were a couple of different holes that I found that needed to be filled. One was modeling. And my undergraduate degree was computer science, and I already sat in front of a computer my whole life. Didn't want to do that, so modeling didn't appeal to me. But since I've been in sales in the past, having a sales guy that can actually bridge the gap between the technology and the application of that technology is where I really shine. Turning U values into something somebody can digest, or air infiltration ratings into something they can digest, is a superpower, maybe. So it's that bridging the gap is where I'm filling, that hole essentially. Between technical products and how the building world puts them into use.
Which is a huge gap.
It is.
I mean, I know for anyone watching, that's why we're doing this, is to help people get that bridge gap, because there's just a lot to know, and it's hard to know who to trust.
There is.
And it's knowing you find the right people to work with, or looking out from a place of integrity to say, how can I get the best building I can? Well,
Right.
Following John's path, the checklist that we're doing, and that's going to be a great help, but reach out to great people such as Todd that are helping people on a daily basis make the right decisions, get the right products, and help them make homes that are going to be outstanding for decades and decades and future generations.
Exactly. So that's our whole thing, is helping builders, architects, building owners, homeowners achieve the energy efficiency objectives that they want to achieve, and we do it through a number of different products, not just the Sega products, but we represent a number of different manufacturers.
Beautiful.
Yeah.
So, Todd, thank you so much, man. Really appreciate it.
Thank you.
All right.